I would like to welcome you in this new chapter where we are going to be trying to put into practice many of the things we had a chance to learn about in the chapter here. And we are going to design a collection class which has the ability to store a bunch of things. So for example, our collection could store a bunch of integers, it could store a bunch of doubles, it could store a bunch of characters. We could really store any kind of thing in here, and we're going to see how we can model this in this chapter. Our collection will have a bunch of features. For example, we want to have the ability to add items or elements in. We want the ability to remove a single item, and we want the ability to remove multiple instances of a single element, and we can set up a remove all method to do that for us. We also want to support a bunch of other operators. For example, we want the addition operator to add two collections up and return a copy containing the concatenation of two collections. You're going to see how this works in a minute. Additionally, we also want to be able to print this to stdc out, and we want to support copy constructors and copy assignment operators. And we are going to support all these things on our collection type. Before we look at some code though, let's try and make sure we understand what this collection is going to do. Here we have a simple representation of what we might store in our collection. So suppose this entire thing here is our collection, and we are maybe storing in integers, and we have some values in. We have in 1, 2, 3, 4, 5, 6, 7 elements. So the size is 7 at this moment. I want you to know this. And the capacity is the total number of slots we have in our current collection. And if we count that, we're going to see that our capacity is 10 at the moment. So this is the setup we might do. And we have two properties in our collection. We have a size and a capacity. The size is the actual number of elements we have in our collection. The capacity is the total number of slots that could store elements that we have. And some of those slots might be empty, as we have in here. For example, the grayed out slots here are empty and they don't contain any element at the moment, but we reserve the right to use them to store things. Okay, so this is the idea here. We can add elements in our collection. For example, the last element here is 11, but we can add another element and make it a 9. And now the last element is going to be a 9 here. And you see that our size has gone up. Now our size is 8. The capacity is still 10. We can see that right here. We can add another element. Let's do that. And that element is going to show up after 9. Let's do this. That's a 15. This is going to bring our size to 9, and our capacity is going to stay at 10 because that's the number of slots we have. We can add another element and bring our collection to full capacity. The last element is going to be 17. Now our size is going to be 10 and the capacity is going to be 10. This is the setup we have here. Now, what if we want to add other elements? We want our collection to have the capacity to grow its size if we want to store more elements than we can currently fit in. For example, now the capacity is 10, but if we want to add another element, we need to extend this collection here, and we can do that. So what we are going to do, we are going to extend the number of slots we have, and we are going to add 3 more. We can do something like this. And what we just did, we just added in 3 more slots. And these are the slots here. And after we extend the capacity, we just added in a new element, which is this 18 here. This is going to bring our size to 11 and our capacity to 13. Hopefully you can really see this. This is something we can do. Another thing we want to be able to do is to remove elements. And for example, suppose we want to remove the 11 element here. Before we remove elements, notice that we have a size of 11. If you count the elements, you're going to see that we have 11 elements and our capacity is 13. Keep this in mind. Now, if we want to remove this 11 element, what we could do is remove this 11 we have here and grab the last element and replace that in this location here. We could do that. So this is going to become an 18, and we are going to reduce our size and bring that to 10 elements because we just removed one element. So if we do that, we're going to end up with a situation like this. And our size is now going to be 10. Hopefully you can see that. And our capacity is not going to change. It is going to stay at 13. This is something we can do in removing elements. So the operation to really remove elements is to target the element that you want to remove. We are going to take the last element and store that in that slot and then reduce the size, effectively eclipsing the last element in our collection here. This is what we are doing. Let's repeat that and try to remove the 8 here. So what we are going to do, we are going to take the last element and use that to eclipse what we have in our slot here. So this is going to stop being 8. It is going to be 17. And notice that it is just a copy. So we are copying the value we have in the last slot and putting a copy of that in our target slot here. This is what we are doing. After we do this, we are going to reduce our size to this location. So this element here is going to be grayed out because our size just became 9. So we are going to end up with a situation like this. This is what we are going to have. It is also possible to remove multiple elements containing the same value. So if we look at our collection here, we have a 5 here, we have a 5 here, and we have another 5 here. If we want to remove them all, we can have a function to remove all, but that function internally is going to be removing elements one by one. So we could target this 5 here, which is the first element, and we are going to do the same operations we did to remove elements. So we are going to take the last element and use that to eclipse the 5 we have in here. So this is going to stop becoming a 5. It is going to become a 15. And we are going to eclipse the last element and reduce the size to this location. Once we do that, we are going to end up with a situation like this. And we will have the second 5 element to remove. We are going to repeat the same operation. So we are going to eclipse that with whatever we have in our last slot. So the 9 here is going to be copied into this location, and this is going to become a 9. And we are going to eclipse the last element and reduce the size. And this guy here is going to be grayed out. Once we do that, we are going to end up with a situation like this. Our size is going to become 1, 2, 3, 4, 5, 6, 7. So if we want to keep track of this, this is going to be a 7. Our capacity is going to stay at 13. This is something we can do. We still have the last element to remove, which is this 5 here. So what we can do is take the last element and use that to eclipse that. We're going to copy this in. So this is not going to become a 5 anymore. It is going to be 18 in here. And the size is going to reduce to be at this location here. So this element is going to be grayed out. Once we do that, we are going to end up with a situation like this. And we have successfully removed all the 5 elements in our collection here. This is something we can do, and we will see ways we can achieve these things in code. We also want a bunch of operators. For example, we want a compound addition operator. And if we look at what we have here, we have a collection, which is box 1. We have another collection. And if we use this operator, we can do something like this and say box 2 add equals box 1. What this is going to do, it is going to take box 1 and add that to box 2. And the result of the operation is going to be stored in box 2. So we are going to end up with a situation like this. So box 2 is going to really be an addition of box 2 and box 1. You see what we had in box 1 is 10 and 20, but we also have all the data from box 1 appended. So 1, 2, and 3, we have all these things stored in our box 2, and box 1 is really not going to change because we just copied data from it and stored that in box 2. This is what we can achieve with our compound addition operator here. We can also set up an addition operator. This is just going to add up box 1 and box 2 and store the result in a new copy. And this is the situation we are going to end up with here. We want these kinds of operators in our collection type. Okay, so one way we're going to achieve this, we are going to set up a bunch of classes to model these things. We are going to be using our stream insertable interface to set up the output stream operator. This is just one way to do this. If you want, you can set up an output stream operator directly in this class. That's also going to work. One thing I want you to notice is that because we want the ability to change the type that we store in this collection on the fly, we are going to be using a type alias for the type that we are storing in here. And we are going to be using this alias in our code. So this is going to be the thing we use in our member variables or member functions. This is going to be storing the type that is being wrapped by our container here. And we are going to be using a dynamic array. You see, this is a pointer, and we can dynamically allocate memory from the heap to store an array of these elements. And we are going to set up a bunch of member functions to wrap around this array and do all kinds of crazy things. So this is the setup we are going to do. Now that you know this, we are going to head over in the next lecture and start setting up this collection type, and it is going to have the ability to set up a constructor. So we are going to do this constructor in the next lecture. We will set up a copy constructor and a default constructor as we have here. And we will have a destructor which is going to destroy this thing when our collection here goes out of scope. Notice that we have our two member variables. One is going to be storing our capacity. The other is going to be storing our size. And all these things are really going to work. The last thing I don't want to ignore is that we have our stream insert method, which is going to be forced on us by the stream insertable interface that we are inheriting from here. And this is going to allow us to print our collection on SDDC out. And this is going to work really well. Now that we know this, we're going to head over to the next lecture and start putting this together.